Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB of the quadrilateral is equal to 4 units, side CD equals to 2 units, and we also know that side CB or BC of the quadrilateral ABCD is equal to side AD. AD equals to BC, and we also know that angle ABC, this angle is a right angle, and angle BAD, this angle equals to 30 degrees, and we want to find out the area of this quadrilateral ABCD. So we'll start with the first method. In the first method, from point D, we will draw perpendicular to AB. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point D to AB as point E. And we will define line segment DE as A. That is to say, line segment DE equals to A units in its length, and so actually in triangle ADE we know that triangle ADE, we know that sinus 30 degrees, this angle equals to 30 degrees in triangle ADE or triangle AD. Sinus 30 degrees equals to A over AD. A over AD I'll repeat again. In the right triangle AD, sinus 30 degrees equals to A over AD. We will multiply equation number 1 by AD, and we know that sinus 30 degrees is equal to 1 over 2, so 1 over 2 will be equal to AD, and it equals to A. So we multiplied equation number 1 by AD, and we got that AD over 2 equals to A. We will multiply equation number 1 by 2, and we will get that according to equation number 1, AD equals to 2A. We found out that AD equals to 2A. So here AD, the hypotenuse of triangle ADE, is equals to 2A. But it is given us in the question that AD equals to CB. AD equals to CB. AD equals to CB. And we found out that AD equals to 2A. From this equation, we conclude that CB also equals to 2A. CB equals to 2A. So here we can so CB equals to 2A. Okay. So in the next step, from point D, we will draw perpendicular to CB. So this angle is a right angle equals to 90 degrees, and this angle, it is also a right angle, that is to say it equals to 90 degrees. We will define the touching point between the perpendicular from D to CB as point F. So we will focus on quadrilateral DFEB, but before that I will present to you a new rule. Rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. I'll repeat on rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So actually, if we focus on quadrilateral DFEB, this quadrilateral, quadrilateral DEFB, according to rule number 1, the sum of its angles must be equal to 360 degrees. So if we define angle EDF as X, then the sum of the angles in quadrilateral DEFB must be equal to 360 degrees. That is to say, angle X plus the sum of the three right angles, that is actually 90 degrees times 3, that is 270 degrees, must be equal to 360 degrees according to rule number 1. I repeat again. On quadrilateral DEFB, the sum of its angles must be equal to 360 degrees according to rule number 1. That is to say, the size of angle X plus the sum of the three other angles, that is actually 270 degrees, must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees is equal to 90 degrees. So we found out that angle X is the right angle, that is to say, it equals to 90 degrees. So we substitute angle X by a right angle. You can see here in quadrilateral DEFB we have 4 right angles, and we have also rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. If not a square, it must be a rectangle. So repeat rule number 2 again. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So because of the fact that quadrilateral DEFB has 4 right angles, according to rule number 2, it is at least a rectangle. So according to rule number 2, quadrilateral DEFB is a rectangle. So you write the conclusion. According to rule number 2, quadrilateral DEFB is a rectangle because of the fact that it has 4 right angles. According to rule number 2. Okay? Quadrilateral DEFB is a rectangle because it has 4 right angles. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I repeat on rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So, therefore, because of the fact that quadrilateral DEFB is a rectangle, its opposite sides must be equal to each other. That is to say, according to rule number 3, DE equals to FB. DE equals to FB. That is according to rule number 3. This rule. DE equals to FB according to rule number 3. But we defined DE as A. D equals to A according to our definition. So from this equation, we will derive that FB also equals to A. FB equals to A. So we can write here that FB equals to A. And what is the size of CF? CF equals to CB minus FB. CF equals to CB minus FB. I'll repeat again. CF equals to CB minus FB. You can see it easily from the drawing. So CF equals to CB. CB is to A. CB is to A minus EB. EB is A. So CF equals to 2A minus A. 2A minus A is A. So we found out that CF equals to A. So we can write it down that CF equals to A. Okay. So here we will join together points D and B by a straight line. And we will prove the triangle DFB, triangle CDF, is perpendicular to triangle BFD. I will repeat again. We will prove the triangle CDF is perpendicular to triangle BFD, this triangle. So why those two triangles can go into each other? Actually, we want to prove that triangle CFD is congruent to triangle BFD. Okay, those two triangles can go into each other. Why those two triangles can go into each other? First of all, CF equals to FB equals to A units. CF equals to FB equals to A units. CF equals to FB equals to A units. Those two angles are equal to each other, they are both equal to 90 degrees. So angle CFD is equal to angle BFD, and both angles are right angles, that is to say they are equal to 90 degrees. I'll repeat again. Angle CFD equals to angle BFD, and they are both right angles, they are equal to 90 degrees. And DF is the common side, it belongs to both triangles, so we can write down that DF equals to itself. DF equals to DF is the common side that belongs to both triangles. DF equals to DF is the common side that belongs to both triangles. I'll repeat again. DF equals to DF is the common side that belongs to both triangles. So we actually proved that this triangle CDF, congruent, triangle CDF congruent, this is the sign of congruent, to triangle BFD according to side angle side rule. I'll repeat again. Triangle CDF congruent to triangle BFD according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between those two sides in one triangle congruent to two sides and the angle between them in the other triangle, then you proved that those two triangles congruent to each other according to angle side angle rule. And we proved that those two sides and the angle between them, that is to say this angle in triangle CDF congruent to those two sides and the angle between them, that is to say this angle in triangle DFB. Therefore we proved that those two triangles congruent to each other according to side angle side rule. From the fact that those two triangles congruent to each other, we will conclude that CD equals to DB. CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, the corresponding sides, that is to say CD and DB, must be equal to each other. Okay, CD equals to DB, but it is given us in the question that CD equals to 2 units. CD equals to 2 units according to what is given us in the question. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. Okay. And now I will present to you a new rule or a new law that is actually the law of sines and the law of cosines. The law of cosines. The law of cosines is true in any triangle, so you can write down that in any triangle if we have triangle ABC, that could be any triangle, This is triangle ABC. This angle is angle theta. The length of side AB is A units. The length of side BC is B units. And the length of side AC is C units. Then, according to the law of cosines, A square plus B square minus 2 times AB cosine theta equals to C square. I'll repeat again, A square plus B square minus 2AB cosine theta equals to C square. Here we will subtract C square and also add 2AB cosine theta to this equation, and we will get that A square plus B square minus C square equals to 2 times AB cosine theta Here we will divide this equation by 2 times AB, and we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. And this formula is true in any triangle. Again, cosine theta, the value of this, the cosine of this angle, equals to A square plus B square minus C square over 2 times AB. Okay? So we actually can implement the law of sines, the law of cosines. This is the law of cosines in our drawing in triangle ADB. I will draw triangle ADB again, and we will implement the law of cosines in triangle ADB. Okay? So in triangle ADB, you know that AB equals to 4 units. It is given us in the question. We found out that AD equals to 2A. And we also found out that DB equals to 2 units. Angle DAE equals to 30 degrees. So actually this is triangle DAB, and we will implement the law of cosines on triangle ADB. According to the law of cosines, cosine 30 degrees equals to 2A square plus 4 square over a minus C square, that is actually 2 square, C square is 2 square, it is DB square, that is 2 square, over 2 times AB. 2 times AB is 2 times A is 2A, and B is 4. Okay, so we found out that cosine 30 degrees in this triangle DAB equals to 2 times A squared plus 4 squared minus 2 squared over 2 times 2A times 4. We know that cosine 30 degrees is equal to square root of 3 over 2. Here 2 times A squared is 4 times A squared. 4 squared is 16. Minus 2 squared is 4. 16 minus 4 is 18. Over 2 times 4 is 8, and 8 times 2 is 16, so here we will have 16a. We will multiply this equation by 16a, and we will get that square root of 3 over 2 times 16a equals to 4a squared plus 12. Here 16 over 2 is 8, so I write it down. We will get here that square root of 3 times 8a equals to 4a squared plus 12. I'll repeat again. We got the square root of 3 times 8 times a equals to 4a squared plus 12. We will divide this equation by 4, and we will get that 8 over 4 is 2. So here we get 2 times square root of 3 times a equals to 4 over 4 is 1, so it is a squared plus 12 over 4 is 3. But we also know that the square root of 3 squared is equal to 3, so we will substitute 3 by square root of 3 squared, that is actually 3, plus a squared equals to 2 times square root of 3 times a. So here we will subtract 2 times square root of 3a from this equation, and we will get that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. As you can see, this equation a squared plus square root of 3 squared minus 2a times square root of 3 equals to 0 is very similar to the algebraic identity that states, algebraic identity that states that a squared plus b squared minus 2 times ab equals to 0. And it also equals to a minus b squared. Here in our specific equation, a equals to a and b equals to square root of 3. So we can write down that this equation is actually equals to a minus b squared. A minus b squared. A is a minus b. B is square root of 3 square, and it must be equal to 0. So we got that a minus square root of 3 square equals to 0. We will take a root out of this equation. The square root of 0 is 0. So here we get that if we take root out of this equation, we get that a minus square root of 3 equals to 0, because the square root of 0 is 0. We will add square root of 3 to this equation, and we will get that a equals to the square root of 3 units. So we found out that a equals to the square root of 3 units. We can write here that a equals to the square root of 3 units. A equals to the square root of 3 units. And also a equals to square root of 3 units. And we will focus on triangle DEB. On triangle DEB, according to the Pythagoras theorem, DE square, on this triangle DEB, DE square plus EB square must be equal to DB square. I'll repeat again. On triangle DEB, according to the Pythagoras theorem, D square plus EB square equals to DB square. DB equals to 2 units. Therefore, DB square is 2 square, 2 square is 4. It equals to EB square plus DE square. DE equals to the square root, DE equals to A, and A equals to the square root of 3. The square root of 3 square is 3. So we actually found out that 3 plus EB square equals to 4. We will subtract 3 from this equation, and we will get that EB square equals to 4 minus 3 is 1, and the square root of 1 is 1, so EB equals to 1. So we found out that EB equals to 1. Here we can write down that EB equals to 1 unit. And what is the value of AE? The value of AE, it equals to AB. AB minus EB equals to AE. AB minus EB equals to AE. AB minus EB equals to AE. So AE equals to AB, that is 4 units, minus EB, that is 1 unit. 4 minus 1 is 3, so we found out that AE equals to 3 units. So we can write down that here AE equals to 3 units. Okay, so here, what is the area of quadrilateral ABCD? The area of quadrilateral ABCD actually, the squared brackets here is the sign for the area. It means the area of quadrilateral ABCD is equal to the area of triangle ADE. This triangle is equals to the area of triangle ADE plus the area of rectangle DFBE, the area of rectangle DFBE plus the area of triangle DCF. I repeat again, the area that we are looking for, that is to say the area of quadrilateral ABCD equals to the area of triangle ADE plus the area of rectangle DFBE plus the area of triangle DCF. So the area of triangle ADE it equals to the base of the triangle, that is actually AE, times the I to the base, that is actually DE, over 2. I repeat again, the area of triangle ADE equals to AE times DE over 2. The area of rectangle DFBE equals to EB times BF. Again, the area of rectangle DFEB equals to EB times BF plus the area of triangle DFC, that is actually the area of this triangle is the base of the triangle, that is actually DF, times the I to the base, that is actually FC, over 2. Okay? I'll repeat again, the area of triangle DFC equals to the base of the triangle, that is DF, times the I to the base, that is FC, over 2. But here, according to rule number 3, that the opposite sides of a rectangle are equal to each other. So in rectangle DFBE, this rectangle, the opposite sides of this rectangle are equal to each other. That is to say, EV equals to DF. EB equals to DF. EB equals to DF. Okay, according to rule number 3. But we have already found out that EB equals to 1. EB equals to 1. From this equality, from this equation, we will find out that DF also equals to 1. DF also equals to 1. So the area of quadrilateral ABCD will be equal to the area of triangle ADE, that is actually AE times DE over 2. AE equals to 3 units. DE equals to square root of 3 over 2. So we found out that the area of triangle ADE equals to 3 times square root of 2 over 2 square units plus the area of rectangle DFBE, that is actually EB, that is 1 times BF, that is square root of 3. So the area of rectangle DFEB equals to actually square root of 3 units plus the area of triangle DFC, this is actually equals to df, that is 1 times fc, that is square root of 3 over 2. So in conclusion, we found out that the area of quadrilateral dfbe equals to this expression. So here we will create the common factor for square root of 2, for square root of 3, so we'll multiply it by 2 and then we will divide it by 2 in order to have a common factor with the other two expressions. We will multiply it by 2 and then we will divide it by 2. And then we will have, in the denominator we have 2. 2 is, we have in the denominator, and in the numerator we have here 3 times square root of 3 by plus 2 times square root of plus 2 times square root of 3 is 5 times square root of 3. 5 times square root of 3 plus 1 times square root of 3 is equal to 6 times square root of 3, and 6 over 2 is 3. So in conclusion, we found out that the area of quadrilateral ABCD equals to 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. I'll repeat again. We actually found out that the area of this quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method, from point A we will draw perpendicular to AB. From point A we will draw perpendicular to AB, so here we will get that this angle equals to 90 degrees. And also from point C we will draw perpendicular to CB. So actually this angle will be a right angle because we drew perpendicular from point C, so this is a right angle, it equals to 90 degrees. We will define the intersection points between the perpendicular from point A and the perpendicular from point C as point E. So actually we have quadrilateral is ABCE. In quadrilateral ABCE, we have three right angles. We define the size of this angle as angle x. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So on quadrilateral ABCE, the sum of the angles also must be equal to 360 degrees. Quadrilateral ABCE has three right angles, and the sum of three right angles is 90 degrees. 3 is 270 degrees, plus the size of the fourth angle that is actually defined as x must be equal to 360 degrees according to rule number 1. We'll subtract 270 degrees from this equation and we'll get that angle x equals to 360 degrees minus 270 degrees. It is actually 90 degrees. So we found out that angle x is a right angle, that is to say it equals to 90 degrees. So we'll substitute angle x by a right angle. According to rule number 2, the opposite sides of a rectangle are equal to each other. This is actually rule number 3. The opposite sides of rectangle are equal. First of all, we know that any quadrilateral that has four right angles, like in this drawing, quadrilateral AECB has four right angles, therefore it must be at least a rectangle. So quadrilateral AECB is a rectangle. Is a rectangle because it has four right angles. This is according to rule number 3. Actually it is rule number 2. And according to rule number 3, the opposite sides of a quadrilateral, the opposite sides of a rectangle are equal to each other. So in rectangle AECB, we will get that AB equals to EC. AB equals to EC. This is according to rule number 3, that the opposite sides of a rectangle are equal to each other. But it is given us in the question that AB equals to 4 units. From this equation, we will derive that EC also equals to 4 units. So we can write here that EC equals to 4 units. Likewise, according to rule number 3, in rectangle ECBA, BC equals to AE. BC equals to AE. And if we define BC as x, then from this equation we will get that AE also equals to x. So here actually BC equals to x and AE also equals to x. They are equal to each other. And we know that angle EAB, this angle is a right angle. Okay, we know that this is a right angle. We actually drew this right angle when we drew perpendicular from point A to to AB, and this angle equals to 30 degrees. So 90 degrees minus 30 degrees will be equal to the size of this angle, that is actually angle AED. So 90 degrees minus 30 degrees is equal to this angle, that is actually 60 degrees. So we found out that angle EAD equals to 60 degrees. In the next step, we will join points E and D together by a straight line. And we will join points D and B together by a straight line. First of all, we know that BC equals to AD according to what is given us in the question. BC equals to AD. It is given us in the question that BC equals to AD, but BC equals to X, so AD must be also equal to X. So here, if we focus on triangle AED, on triangle AED we have two equal sides. AE equals to AD equals to X. So I will draw triangle AED in a new page, and we will analyze triangle AED. Triangle AED has two equal sides, so it is very unique triangle. We have triangle AED. This is triangle AD. Triangle AD has two equal sides, that is to say AE equals to AD. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles that are located in front the equal sides, in front of those two equal sides, must be also equal to each other. So if we define one angle as y, then the other angle must be also equal to y because of the fact that they are equal to each other. But what is the sum of those two angles? The sum of those two angles is 180 degrees minus 60 degrees, because the sum of the angles in any triangle is 180 degrees. So the sum of those two angles must be equal to 180 degrees minus 60 degrees, that is 120 degrees. So the sum of angle y plus y is equal to 180 degrees. That is to say y plus y is 2y. 2y equals to 180 degrees. We will divide this equation by 2, and we will get that angle y equals to 60 degrees. Angle y equals to 60 degrees. So actually, we got here an equilateral triangle. So this side will be also equal to x. Triangle AED is an equilateral triangle. That is to say, all its three sides are equal to x, they are equal to each other, and all of its three angles are equal to 60 degrees. Okay? So here ED equals to X. This angle equals to 60 degrees. This angle also equals to 60 degrees because of the fact that triangle EAD is an equilateral triangle. But we know that angle AEC is a right angle. And angle AED equals to 60 degrees. So 90 degrees minus 60 degrees is the value of this angle. This angle is actually the subtraction of 90 degrees from 60 degrees will give us this angle. So we'll focus on triangle DEC. On triangle DEC, according to the law of cosines, triangle DEC, this triangle, we got the equation that states that cosine 30 degrees according to the law of cosines equals to 4 squared plus x squared minus 2 squared over 2 times x times 4, the law of cosines, I will repeat again. On triangle DEC, the law of cosines is true in any triangle, so we can implement it in any triangle. So in triangle DEC, if we will implement the law of cosines in triangle DEC, we will get that cosine 30 degrees equals to 4 squared plus x squared minus 2 squared over 2x times 4. Cosine 30 degrees is square root of 3 over 2, and it equals to 4 squared is 16, minus 2 squared is 4, 16 minus 4 is 12, plus x squared equals to 2 times 4 is 8, x. So we will multiply this equation by 8x, and we'll get that square root of 3 over 2 times 8 times x equals to 12 plus x squared. 8 over 2 is 4, so we got that 4 times square root of 3x equals to 12 plus x squared. So actually x squared plus 12 is 2 times square root of 3 square minus 4 times square root of 2 square is 2 times x times 2 times square root of 3, and it equals to 0. So this equation is very similar to equation that a squared plus b squared minus 2 times ab equals to 0. in our specific equation, a equals to x and b equals to 2 times square root of 3, and we know that a squared plus b squared minus 2ab is equals to a minus b squared. So we can substitute this expression, our specific equation, by a minus b squared. In our specific expression, a minus b squared will be equal to x minus 2 times square root of 2 squared equals to 0. Here we will take a root out of this equation, and we will get that x minus 2 times square root of 3 equals to 0. We will add 2 times square root of 3 to this equation, and we will get that x equals to 2 times square root of 3 units. So we found out that x equals to 2 times square root of 2 units, 2 times square root of 3 units. So here x equals to 2 times square root of 3 units, and also here x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. And the area of that we are looking for is the area of triangle, the area of quadrilateral ABCD will be equal, the area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle BDC. I'll repeat again. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. From point D, we will draw perpendicular to AB, and this will be the height of triangle ADB when the base is AB. So the area of triangle ADB will be equal to the base, that is actually AB, times the height to the base, that this will be h, the height will be defined as h, over 2. So the area of triangle ADB equals to AB times h over 2. What is the value of h? The value of h, we know that sinus 30 degrees equals to h over AD, and AD is 2 times square root of 3. Sinus 30 degrees is 1 over 2. So h so we found out that h equals to 2 times square root of 3 over 2. 2 over 2 is 1, so h equals to square root of 3 units. Therefore, the area of triangle ADB equals to AB, that is 4, times the height, that is square root of 3 over 2. That is to say, the area of triangle ADB equals to 4 times square root of 3 over 2. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 square units. The area of triangle ADB equals to 2 times square root of 3 square units. And we also we have to find out the area of triangle DBC. We will find out the area of triangle DBC according to a special formula that states that the area of triangle BDC is equal to square root of S times S minus A times S minus B times S minus C. When A, B, and C are the left sides of triangle ABC, here we know that DC equals to DB, they are both equal to 2 units, and BC equals to 2 times square root of 2. So A equals to 2, B equals to 2, and C equals to 2 times square root of 3. So the area of triangle BDC will be equal to the square root of, and what is the value of S? The value of S, it is actually the perimeter of triangle ADC over, the perimeter of triangle BDC over 2, and the perimeter of triangle BDC is A plus B plus C, and the semi-perimeter is equal, have to divide it by 2 in order to find out the semi-perimeter. So here A is 2, B is 2, and C is 2 times square root of 3, all divided by 2. So here it is 4 plus 2 times square root of 3 over 2. 4 over 2 is 2, and 2 times square root of 3 units over 2 is square root of 3. So in conclusion, we found out that S equals to 2 plus square root of 3 units. Okay. So the area of triangle BDC will be equal to the square root of, so S is 2 plus square root of 3 units. S minus A is 2, so, and S is 2 plus square root of 3 units. 2 plus square root of 3 units minus 2 is square root of 3 units. S minus B, B is 2, so we'll get the same result, that S minus B will be equal to square root of 3 units. And S minus C, S is 2 plus square root of 2 units, and C is 2 times square root of 3 units, so 2 plus square root of 3 units minus 2 square root of 3 units, it is actually 2 minus square root of 3 units. So here, the area of triangle BDC will be equal to square root of 2 times square root of 2 is 3. And 2 plus square root of 3 times 2 minus square root of 3 is the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. A is 2 and B is square root of 3. A squared is 2 squared, 2 squared is 4. Square root of 3 squared is 3. So A squared minus B squared is 4 minus 3. So in conclusion, 4 minus 3 is 1. And so we found out that the area of triangle BDC is square root of 3 units. So the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC, and we already found out that the area of triangle ADB is 2 times square root of 3 units plus the area of triangle BDC that is actually square root of 3 units. 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we actually found out that the area of quadrilateral ABCD, according to the second method, it equals to 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, in the next step I will summarize the lecture. Actually, we wanted to find out the area of quadrilateral ABCD. We found the area of quadrilateral ABCD in 2 different methods. In the first method, from point D we go perpendicular to AB. We define the touching point between the perpendicular and AB as point E. And we also go perpendicular from point D to CB. We define the touching point between the perpendicular to CB as point F. And then, so we have here triangle ADE is a right triangle. In triangle ADE, we know that sinus 30 degrees equals to A over AD. Sinus 30 degrees equals to A over AD. But sinus 30 degrees is 1 over 2. And we multiplied this equation by AD, and we got that AD times 1 over 2, that is actually sinus 30 degrees, equals to A. Then we multiplied this equation number 1 by 2, and we got that AD equals to 2A. AD equals to 2A, here AD equals to 2A. But because of the fact it is given us in the question that AD equals to BC, so if AD equals to BC and AD equals to 2A, then BC will be also equal to 2A. Okay, AD equals to 2A, so AD equals to BC, it is given us in the question, and AD equals to 2A, therefore BC will be also equal to 2A. Then I presented to you rule number 1 that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral BFED, in this quadrilateral, we have 3 right angles. So if we define the 4th angle as x, then we know that the sum of those 4 angles must be equal to 360 degrees. The sum of 3 angles, the sum of the 3 right angles is 90 degrees times 3, that is 270 degrees, plus the size of the 4th angle that we defined as angle x must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle x equals to 90 degrees. We found out that this angle is a right angle, so quadrilateral DEFB has 4 right angles, and according to rule number 4, Rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. Therefore, we relate to quadrilateral DEFB as a rectangle, and we have also rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So in our rectangle, it means that ED equals to BF, ED equals to BF according to rule number 3, but we define DE as A. DE equals to A according to our definition. Therefore, BF also must be equal to A. Okay, so we know that AD equals to CB and AD equals to 2A, therefore CB also equals to 2A. And what is the value of CF? CF equals to CB minus FB. CF equals to CB minus FB, that is to say CB is 2A and FB is A, so CF equals to 2A minus A, that is to say CF equals to A. So if I know that CF equals to A, then we proved that triangle CDE is congruent to triangle BFD. Triangle CDE, this triangle CDE, we proved the triangle CDF. We proved the triangle CDF is congruent to triangle BFD. We proved that those two triangles congruent to each other. Why they congruent to each other? First of all, we have CF that equals to FB that equals to A. CF equals to BF equals to A. We have angle, those two angles, they are both right angles, therefore they are equal to each other. So angle CFD equals to angle BFD equals to 90 degrees. And we have also a common side. DF is a common side, it belongs to both triangles, so DF equals to DF is a common side. And we actually proved the triangle CDF congruent to triangle BFD according to side angle side rule, and therefore we can conclude from it that CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. But we know that CD equals to 2 units. It is given as an equation. From this equation we will derive that BD also equals to 2 units. BD also equals to 2 units. Then I presented to you the law of sines in any triangle. A square plus B square minus C square equals to A square plus B square minus C square. Actually, A square plus B square minus 2 times AB cosinus theta equals to C square. We subtracted C square and then we subtracted 2AB cosinus theta and we added C square to this equation, and we got that A square plus B square minus C square equals to 2AB cosinus theta. Then we divided this equation by 2AB and we got that cosine theta equals to A square plus B square minus C square over 2 times AB. And we can implement the law of cosine in our drawing, because we can implement the law of cosines in triangle ADB. In triangle ADB, this is triangle ADB. We get that if we implement the law of cosines in triangle ADB, we get that cosine 30 degrees equals to 2A square plus 4 square minus 2 square over 2AB times 4. Okay, and we know that cosine 30 degrees is square root of 3 over 2. 2A square is 4A square. 4 square is 16, 2 square is 4, and 16 minus 4 is 12. So we got the numerator 4a squared minus plus 2f over 2 times 4 is 8 and 8 times 2 is 16. So in the denominator we have 16a. We multiplied this equation by 16a and we got that 4a squared plus 2f equals to 16a times square root of 2 over 3. 16 over 2 is 8. So we got that square root of 3 times 8a equals to 4a squared plus 12. Here we divided this equation by 4. 8 over 4 is 2, 4 over 4 is 1, and 12 over 4 is 3. So in conclusion we got that 2 times square root of 3a equals to a squared plus 3. 3 is square root of the square root of 3 square, and a square plus square root of 3 square equals to 2 times square root of 3a. So here we got that a square minus square root of 3 square. We subtracted 2 times square root of 3a from this equation, and we got that a square minus square root of 3 square minus 2 times a times square root of 3 equals to 0. It is very similar to the algebraic identity that a square plus b square minus 2 times ab equals to a to 0, and it equals also to a minus b square. So we can substitute this expression by a minus b square. Here in our specific equation a equals to a and b equals to square root of 3 units. So a minus b square will be equal to a minus square root of 3 square, and it equals to 0. We will take a root out of this equation and we get that a minus square root of 3 square equals to 0. We added square root of 3 to this equation and we got that a equals to square root of 3 units. So found out that a equals to square root of 3 units. Then we implemented the Pythagoras theorem in triangle BED. In triangle BED, according to the Pythagoras theorem, DE square plus BE square equals to DB square. DE equals to square root of 3. So DE square is square root of 3 square is 3. Plus EB square is the missing variable equals to BD square. BD is 2, so BD square is 2 square, 2 square is 4. Here we subtracted 3 from this equation and we got that EB square equals to 1 and the square root of 1 is 1. So we found out that EB equals to 1. And what is the value of AE? AE equals to AB minus AB. AB equals to AE equals to AB minus EB. So AE equals to AB, that is 4 units, minus EB, that is 1. So in conclusion we got that AE equals to 4 minus 1, that is 3. So A equals to 3 units, and then, so the area of quadrilateral ABCD equals to the area of triangle ADE plus the area of rectangle EDFB plus the area of triangle CDF. Okay? And the area of triangle ADE, the area of triangle ADB is equal to the base of the triangle, that is AB, times the height over 2, AE times DE over 2, AE is actually the area of triangle ADE, it is actually AE times DE over 2. And AE is equal to 3 units, ED equals to square root of 3 units, so it is actually 3 times square root of 3 over 2. This is the area of triangle ADE, plus the area of rectangle EDFB, it is actually EB times BF. EB times BF, EB equals to 1, and DF equals to 1, and EB equals to square root of 3, actually ED equals to square root of 3 units, so it is 1 times square root of 3 units over 2, that is actually square root of 3 units over 2, plus the area of triangle DCF. The area of triangle DCF is DF times CF over 2, DF times CF over 2, DF is 1, so it is 1 times square root of 3 over 2. So here we multiplied square root of 3 by 2 and then we divide it by 2 in order to have a common factor with these expressions, and we got that 3 times square root of 3 plus 2 times square root of 3 is 5 times square root of 3, and 5 times square root of 3 plus 1 is 6 times square root of 3, and 6 over 2 is 3. So in conclusion, we got that the area of quadrilateral ABCD equals to 3 times square root of 3 units. So we finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD using the second method. According to the second method, we actually draw perpendicular to AB from point A, so this angle is 90 degrees, and we also draw perpendicular from point C to CB, so this angle will be also equal to 90 degrees, and we define the intersection point from the perpendicular to C, from the perpendicular from C and the perpendicular from A as point E. This is the intersection point between those two perpendiculars. And then, so actually here we have quadrilateral ECBA that has 3 right angles. We define this angle as X, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees according to rule number 1. So the sum of 3 right angles, that is 270 degrees, plus the size of angle X must be equal to 360 degrees. We subtract the 270 degrees from this equation, and we got that angle X equals to 90 degrees. So quadrilateral AECB is 4 right angles, and therefore, according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. So this quadrilateral ECB ABC is a rectangle according to rule number 2, and the opposite sides of a rectangle are equal to each other, so AB equals to AC, AB is equal to 4, so from this equation we will derive that EC also equals to 4, and we define CB as X, and according to the rule that the opposite sides of a quadrilateral are equal to each other, then CB equals to EA, CB equals to AE, and BC is defined as X, so AE will be also equal to X. Then we focus on triangle AED. We know that AD is equal to CB and CB equals to X, so AD also must be equal to X. So here in triangle AED we have 2 equal sides. AD equals to X, AD equals to AD AE equals to AD, both of them are equal to x, and this angle is actually 90 degrees minus 40 degrees, this angle is 60 degrees. So in this triangle we have two equal sides, and the sum of those two, in front of those two equal sides there are equal angles, that is to say those two angles must be equal to each other. So if one angle is y, then the other angle must be also equal to y, and y plus y must be equal to 180 degrees minus 60 degrees, that is to say y plus y equals to 120 degrees. That is to say 2y equals to 120 degrees. We divided this equation by 2, and we got that angle y equals to 60 degrees. Therefore, triangle AED is an equilateral triangle. All of its sides are equal to each other, and all of its angles are equal to 60 degrees. Triangle AED is an equilateral triangle. So in triangle ECD, according to the law of cosines, triangle ECD, according to the law of cosines, cosine 40 degrees must be equal to 4 square plus x square minus 2 square over 2 times x times 4. Then cosine 30 degrees is equal to 3 over 2. 4 square is 16, minus 2 square is 4, 16 minus 4 is 12. So in the denominator we have here 12 plus x square. In the numerator we have 12 plus x square, and in the denominator we have 2 times 4 is 8. So in conclusion, in the denominator we have 8 square. Here we multiply this equation by 8 square, and we got that 8 square times root of 3 over 2 equals to 12 plus x square. 8 over 2 is 4. So in conclusion, we got this equation. We can present this expression as x squared plus 2 times square root of 3 square, because 12 is 2 times square root of 3 square, minus 2 times x times 2 times square root of 3, that is actually the expression 4 times square root of 3 square. And according to the algebraic identity, that a square plus b square minus 2ab equals to 0, and it also equals to a minus b square. In our specific expression, a is equal to x and b equals to 2 times square root of 3, and according to this algebraic identity, a minus b square equals to 0. So here a is x and b is 2 times square root of 3, so x minus 2 times square root of 3 square will be equal to 0. We took the root of this equation, and we got that x minus 2 times square root of 3 equals to 0. We added 2 times square root of 3 to this equation, and we found out that x equals to 2 times square root of 3 units. Then the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC, and the area of triangle ADB equals to the base of the triangle, that is AB, times the eye to the base, that is actually h, over 2. The area of triangle ADB equals to the base, that is AB, times the eye to the base, that is h, over 2, and sinus 30 degrees equals to h over 2 times square root of 3, that is to say h equals to square root of 3. Therefore, the area of triangle BDC will be equal to AB, that is 4 units, times the height, that is square root of 3 units, over 2. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 square units, And then we found out the area of triangle BDC according to the special formula that the area equals to the square root of S times minus A times S minus B times S minus C. When A, B, and C are the side lengths of triangle BDC, and S is the semi-perimeter of triangle BDC, that is actually the perimeter over 2. Okay, the perimeter over 2. We know that A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 2 units. And the area of triangle BDC equals to this expression. And again, the S is the semi-perimeter of triangle ABC, that is the perimeter over 2, and the perimeter over 2 of triangle ADB, of triangle BDC, is equals to A plus B plus C over 2. A is 2, B is 2, so 2 plus 2 is 4, and 4 plus C, that is 2 times square root of 2, it will give us 4 plus 2 times square root of 2, and then we will have to divide it by 2, and we will get that the semi-perimeter of triangle BDC is 2 plus square root of 3 units. When we put the value of S inside this equation, we will get that the area of triangle BDC equals to square root of 2 units, square root of 3 units, and the area of triangle of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC, that is actually 2 times square root of 3 units plus 1 times square root of 3 units. That is to say, the area of triangle or the area of quadrilateral ABCD equals to either 3 times square root of 2 square units, or in terms of numbers, it equals to 5.1.96 square units. Okay? Here I actually repeat again that the semi-perimeter of triangle BDC equals to A plus B plus C over 2. A is 2, B is 2, and C is 2 times square root of 3. 2 plus 2 is 4, plus 2 times square root of 3, all divided by 2. 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3, so the semi-perimeter of triangle BDC is 2 plus square root of 3 units. And when we put the value of S inside this formula, we got that here it is S, and S is 2 plus square root of 3, and S minus A is 2, so S minus A will be equal to square root of 3, S minus B will be also equal to square root of 3, and S minus C is equals to 2 minus square root of 3, and here square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3 is like the algebraic identity that says that A plus B times A minus B equals to A squared minus B squared. And so A is 2, so A squared is 4, and B is square root of 3, and square root of 3 squared is 3. So in conclusion, we got that the area of triangle BDC equals to the square root of 3 times 4 minus 3 is 1. 4. So the area of triangle BDC equals to the square root of 3 units, and the area of quadrilateral ABC equals to the area of triangle ADB plus the area of triangle BDC. That is, the area of triangle ADB is 2 times square root of 3 units, and the area of triangle BDC is the square root of 2 units, 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we found out that the area of quadrilateral ABC equals to 3 times square root of 3 units. So in terms of numbers, it equals to 5.196 square units. Okay, thank you very much.